Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today's discussion will be related to the construction of the isometric projections of the frustum of the cones. Now here we have a frustum of the cone. So to begin with, we need to know what is the frustum of a cone. So whenever a cone has been cut by a cutting plane parallel to its base, so the remainder portion of the solid which is containing the base, this portion of the solid is called frustum of the cone. So we are given that we have a frustum of a cone in which the upper diameter, the diameter of the top surface happens to be 30 millimeter. The diameter of the base of this frustum of the cone, so this happens to be 50 millimeter. So this diameter of the cone is equal to 50 millimeter, and the height of this frustum, it happens to be 70 millimeter. So we are required to draw the isometric projections of this frustum of the cone. So let us read out the statement. We are required to draw the isometric projections of a frustum of a cone having diameter 30 millimeter at the smaller end. So this is the 30 millimeter diameter of the top surface. Then the diameter 50 millimeter at the bigger end, that is, it is the diameter at the base, and the axial height is 70 millimeter. So this is the height of the axis of the frustum of the cone, which is equal to 70 millimeter. The cone is resting on its bigger diameter on the horizontal plane with its axis perpendicular to HP. Now let us see how we actually project this in the 3D view over there. So this is the uncut cone. So this is the complete cone in the normal position, and we have cut this cone in such a way that this diameter happens to be 30 millimeter, the base diameter will be 50 millimeter, and the height of the axis of this frustum will be 70 millimeter. So you see, this cone has been cut by a cutting plane which happens to be parallel to the base. So the upper portion which has been cut, it will be discarded, right? So this portion we don't need. So this remaining solid we are interested in. So this remaining solid, it is called frustum of the cone. And when we draw the front view and the top view of this frustum of the cone, so this is what we will be getting. Corresponding to the top face, this diameter of the top face of the frustum of the cone is 30 millimeter. So this is 530. That is, this diameter happens to be 30 millimeter. And we cannot draw this 30 millimeter circle onto the isometric projection straight away, because this circle will be looking like an ellipse in the isometric projection. So what we'll be doing, we have to inscribe this circle into a square, and the side of the square will be how much? This will be 30 square. That is, this edge will be 30 and this edge will also be 30. Similarly, the top view corresponding to the base, this will be having the diameter is equal to 50 millimeter. So this is 550, and then once again this circle will be inscribed within a square, right? So this is a square which is having the dimension 50 by 50. So this is SQ50. Okay, so with this square constructions, we are able to draw ellipses onto the isometric projection. So this is the top view. Now let us draw the front view. So in the front view, the axis height, we know the axis height is equal to 70 millimeter, and then once we take the projections upwards, so this is going to be the top surface. This is this top surface of the frustum of the cone. So this is the top surface of the frustum of cone. It will have the length over there 30 millimeter, whereas this length of the base will be 50 millimeter. So this is the front view of the frustum of the cone, whereas this is the top view of the frustum of the cone. So let us see how we can draw these projections onto the isometric axis. So first of all, we need to draw the isometric scale, that is all the distances which are given to us 30, 50 and 70. So all these dimensions, they need to be translated or you see confirmed into the isometric length. So we have to transform the true length into the isometric length, and so these transformed isometric length dimensions will be drawn onto the isometric projections over there. Now we start with the construction of the horizontal ground or the datum line, and then here we have the center point. From the center point, the x-axis, that is the isometric axis, and the z-axis, again the isometric axis, will be drawn both at an angle of 30 degree each, right? Then the height of this particular frustum of the cone will be drawn along the y-axis. So let us start with the construction. So on the base, we have to draw a square of 50 millimeter size, right? So this is this 50 millimeter. So this is the 50 millimeter size of the square that we need to draw at the base, and the height of this particular frustum we have to take as 70 millimeter. So let us start with the construction. So this is the 70 millimeter edge that we have drawn, and on the base, so this base will be drawn along the x and z plane over there, right? So one edge of the square of the base will be lying on the x-axis, while the second edge of the base of the square will be lying on the z-axis over there. So let us draw this. So this is the distance of, please check, 50 millimeter on the x-axis. So we have marked 50 millimeter on the x-axis, and now this is the height. So this height, that is the y-axis, we have taken as 70 millimeter. So this height is equal to 70 millimeter. Now this vertical edge, and another vertical edge we will be drawing from here. But let us complete the base first of all. So we have to draw two isometric lines which will be parallel to the isometric axis. So this isometric line or the isometric edge, so this has been drawn parallel to the z-axis, and this isometric line corresponding to one of the edges of the base, this has been drawn parallel to the x-axis. Now this completes the construction of the square which is corresponding to this circular portion. This was the circular portion corresponding to the base of this frustum of the cone. Now we are going to complete the top face as well. So the third vertical edge which will be visible to the observer has been drawn, and once again this edge will be parallel to the x-axis, and this edge that we have drawn, this is one of the edges of the top face of the frustum of the cone. So this has been drawn parallel to the z-axis. Similarly, another one, this edge has been drawn parallel to all of these edges, and finally this edge has also been drawn, which is one of the edges of the top face of the frustum of the cone. And now you see these four edges, they are corresponding to the 50 millimeter size of the square, but we have been provided with this information that the upper circular portion of this particular frustum of the cone is having the dimensions equal to diameter is 30 millimeter. So the square which we will be requiring at the top face will be SQ30. It is not SQ50. So these are basically going to be the construction reference lines in order to construct a square at the top which will be having the dimensions 30 millimeter each. So what we are going to do, that now we are going to find out the center point. So please see, we find out the midpoint of this edge. We have worked out the midpoint of this edge. So these two midpoints, once they are worked out, I can draw the center line corresponding to this edge of the square. Similarly, corresponding to this edge of the square, once again the midpoint has been evaluated, and similarly corresponding to this edge of the square, we have worked out the midpoint, and again center line or the locus line has been drawn. Now we need to have 30 millimeter square at the top rather than 50 millimeter. So this you see, construction of square of 50 millimeter at the top, it will become a guiding reference in order to obtain the square of 30 millimeter at the top. So you see what we are going to do with respect to this center. Now I have drawn two projections line over here. So these projection lines, they are having an offset of 15 millimeter from the center line. So there is an offset of 15 millimeter towards right, and again there is an offset of 15 millimeter towards the left. So the distance between these two projection lines become 30 millimeter. So this will be housing two of the edges of the top face of the square over there. Now let us work out the remaining two edges. So for that, this is 30 SQ, that is 30 square, right? Now let us work out another two projectors which will be parallel to the second center line. So this is my second center line. So again, this line and this projection line, this projection line and this projection line, both are having an offset of 15 millimeter from this particular axis line over here, or the center line over here. Now again, the distance between these two projection lines will be 30 millimeter. So we get a square 30 millimeter by 30 millimeter. So this is also 30, this is also 30, right? So the square of size 30 has been obtained using these guidelines or the reference line, whereas at the bottom we are having the square which is drawn with an edge length equal to 50 millimeter. Now we have to use the 4 center method to draw ellipse at the top, and again 4 center method will be used to draw ellipse corresponding to the square of 50 at the bottom. So let us start with construction of the ellipse at the top, because circle appears like an ellipse in the isometric projection. So here please check, we have got a square of 30 millimeter side. So once we draw the square on the top face, we will find that the square appears to be a rhombus in the top view in the isometric projections over there. So in the top view we are going to get a rhombus corresponding to SQ30. Now once we obtain the rhombus, please check, this is the major diagonal of the rhombus, this is the minor diagonal of the rhombus. Now we have to focus upon this minor diagonal. So we know that this is the minor diagonal, and we have already obtained the midpoints of the 4 edges of the square which is lying on the top. Center point 1, center point 2, center point 3 and center point 4. Now from the both of these corners, both of the ends of this minor diagonal, we are going to join two projectors which will be joining the midpoint of the opposite edges. So corresponding to, please check, this corner, the opposite edges are this one and this one. So this is the opposite edge, this is also the opposite edge corresponding to this point or this end of the minor diagonal. So from this point, first projector is drawn. From this point, once again the second projector is drawn. Similarly, from the second corner of the minor diagonal, these are the two opposite edges of the square. So these are the midpoints. Now from this opposite end, we are going to draw, from this corner point we are going to draw projector lines to the midpoints of the opposite ends. Now we have obtained the 4 centers over here. What are those centers? Center 1, center 2, center 3, center 4, right? So these are 4 centers. Now let us work out the arcs using this center. Please check, my radius will be this one or this one. So using this C1 as the center, radius is equal to this or this length, I am going to draw an arc using a compass over there. Next, my center 2 is this. So using this as my center C2, my radius will be this one. Please check, this will be my radius or this will be my radius. Okay, so using these two radii which are equal, I am going to draw the second arc over here. So second arc has been drawn from the center 3. So this is my radius or this is my radius. So using C3, center 3 point, so again using this radius which is equal to this radius, another arc will be drawn using the compass. And finally C4, this is my 4th center. So with this as center C4, I am going to measure this radius or this radius, and again with C4 as center I am going to draw the arc number 4, right? So ellipse construction, which is corresponding to the circular portion of the frustum of the cone, has been developed at the top face, right, of this frustum of the cone. Now let us draw the ellipse at the bottom as well. So we have a square of 50. So square of 50 is represented as a rhombus in the isometric projection. Now once again we have the major diagonal and this one is the minor diagonal. So our focus is once again on the minor diagonal. So we have obtained the midpoint of all the 4 edges of the square having the edge length is equal to 50 millimeter. Now from each corner of the minor diagonal, so there are 2 ends of the minor diagonal. From the first end of the minor diagonal, I am going to draw projector onto the opposite edge on this side. Similarly, from this point, that is this end of the minor diagonal, another projector will be drawn to the opposite edge midpoint, which will be joining here. Similarly, corresponding to the second end of the minor diagonal, I am going to draw 2 projectors which will be joining the midpoints of the opposite edges. So this is the second opposite edge. So this projector will be joining the midpoint of the second edge as well. So once we have made this construction, so the 4 center points, they have been located once again. So let's name them C1, C2, C3, C4. Now with C1 as the center, the radius is equal to this one. So this is my radius. Both of these radii, they are equal. So I will be drawing the first arc using the compass over there. So C1 will be my center point. Now with C2 as center, radii equal to this one or this length, I am going to draw the second arc between these 2 points over there. Similarly, C3 will be my center point. I'll open my compass equal to this much radius or this one, both of them they are equal. So the third arc will be drawn using the compass over there. And finally this is my 4th center point. So this is going to be my radius or this is going to be my radius. So I'll open compass equal to this distance or equal to this distance, and the 4th arc will be drawn using the compass over there. So the perfect ellipse has been drawn at the base, which corresponds to the circular portion of the base of this particular frustum of the cone. Now having obtained both of this circular portions at the base as well as at the top, now I am going to draw tangent from this point of the top. It will be joining the base at this point. Similarly, the tangent from the external most point from the top, and it will be joining the last point over here on the base, and all the points of the top surface that is corresponding to the top face of this frustum, they will be visible to the observer. So I can darken it fully. So this completes my top portion. Now regarding the bottom portion, so this semicircular portion of the bottom, that is the base of this frustum of the cone, will not be visible to the observer. So observer will be able to see only the external semicircular portion of this cylindrical portion of the base of this cone. So this portion I am going to join over there. So once I join, I will be getting the completion of the construction of the isometric projections of frustum of the cone. So this is the way we can go about constructing the isometric projections of frustum of a cone which has been cut by a cutting plane parallel to the base of the solid or the base of the cone, right? So this is all for today. So this discussion will help you to develop a proper understanding about the construction of isometric projections of frustum of the cone. So thank you very much.